Albert Einstein has enjoyed scientific celebrity status for decades. He also has a lot of critics, although you don't hear too much about them from popular science sources. Ironically, I sometimes wonder if he would be more sympathetic to his detractors if he were still around today, and I say that in all seriousness. I am no Einstein, he once joked, in response to the adulation that began in his lifetime. Let's see what else he had to say that might challenge his hero worship today.
Don't listen to the person who has the answers. Listen to the person who has the question.
Despite its significance today, Einstein never received the Nobel Prize for General Relativity. The Nobel Committee considered it too speculative at the time. He was awarded the Nobel Prize in Physics in 1921 for his work on the photoelectric effect. In 1905, the year he recalls fondly as his annus mirabilis, marvellous year, he earned his doctorate for a dissertation entitled A New Determination of Molecular Dimensions. These facts are worth committing to memory if you ever do science quizzes. According to Wikipedia, yes, I know, the German-born theoretical physicist is widely ranked among the greatest and most influential scientists of all time. Despite his cult hero status, however, many do not even regard him as a scientist, let alone a great. The clue is in the two words, theoretical physics. This rests almost entirely on mathematical modelling, unlike classical science, which emphasises experimentation and observation.
As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality.
To summarize this philosophical viewpoint, one common among critics of Einstein and, apparently, Einstein himself, math should be ancillary, not dominant. Making science subservient to mathematics is putting the cart before the horse, let alone hubristic. Just think epicycles, where the mathematical model can make accurate predictions, yet failed to reflect the underlying reality. Quote, I am acutely aware of the fact that the marriage between mathematics and physics, which was so enormously fruitful in past centuries, has recently ended in divorce, close quote, Freeman Dyson. Consider also the amusing case of the Wright brothers. Early last century, Scientific American magazine dismissed their alleged flights years after they had been flying successfully. The magazine's certainty was based on the prevailing wisdom at the time, that heavier-than-air flight was impossible because, well, the maths said so. The importance of mathematics is not denied. Again, the point is that math should follow the science rather than building the science on idealized mathematical models and selectively interpreting data to fit. Furthermore, current models rely on free variables to balance the equations. Dark matter and dark energy are the oft-cited Achilles heel of pop science. They remain undetected after decades of searching, despite allegedly comprising roughly 90% of the universe. Those who pretend there isn't any debate to be had on the dominant role of mathematics in science have a problem, but don't take my word for it. Quote, Physics is mathematical not because we know so much about the physical world, but because we know so little, close quote, Bertrand Russell. Oh, and here's another one from Einstein himself.
Since the mathematicians have invaded the theory of relativity, I do not understand it myself anymore.
Even if you think Einstein had his tongue planted firmly in his cheek at the time, I would suggest that many a true word is spoken in jest. Philosophical issues aside, Stephen Crothers has done a fine job exposing the flaws and leaps of faith in so much math-based cosmology. A noted mathematician from Tasmania, he is counted among the most competent critics of general relativity, the Big Bang, and black holes et al. Quote, Hawking was a pop scientist who ipso facto contributed nothing of value to science. Einstein was the first pop scientist, promoted at some time or another by that other entertainer, Charlie Chaplin. Hawking and the Einstein cult have ruined physics and astronomy, turning them into circus freak shows. Science cannot just wait until they all disappear. Whilst they are active, they are ruining young minds entering science to be caught up in the same rat race, producing more pop scientists. The cycle must be broken, close quote, Stephen Crothers. Yes, I think it is safe to put Crothers in the critical of Einstein club. Einstein coined the term spooky action at a distance, latterly referred to as quantum entanglement. It seems that one particle can know something about another particle instantaneously over a vast distance. This phenomenon is problematic because it breaks the speed of light barrier, supposedly the upper speed limit of the universe. Because it contradicts special relativity, Einstein was compelled to issue a traffic violation.
I cannot seriously believe in it because the theory cannot be reconciled with the idea that physics should represent a reality in time and space, free from spooky action at a distance.
SAD, spooky action at a distance, has been confirmed post-Einstein. This is a big problem for orthodoxy. As a result, we have seen numerous attempts to resolve the contradiction via the mathematical mysticism known as quantum physics. Quantum superposition conjectures that particles can exist in different states simultaneously, much like the criminal who claimed to be at home when he was seen robbing a store. Science fiction can't hold a candle to it, that much is certain. At the very least, the problem reminds us that the door must be left open to other ideas about the universe and, it has to be said, further consideration of concepts abandoned when relativity took the helm. Quote, if you think you understand quantum mechanics, then you don't understand quantum mechanics. Close quote, Richard Feynman. Herbert Dingle, another noted critic of general relativity, served as president of the Royal Astronomical Society in the 1950s. In his 1972 book, Science at the Crossroads, he had this to say, quote, Lorentz, to justify his transformation equations, saw the necessity of postulating a physical effect of interaction between moving matter and ether, to give the mathematics meaning. Physics still had de jure authority over mathematics. It was Einstein who had no qualms about abolishing the ether and still retaining light waves whose properties were expressed by formulae that were meaningless without it, who was the first to discard physics altogether and propose a wholly mathematical theory. Close quote. The Michelson-Morley experiment is often cited as conclusively falsifying ether theory, and this has become scientific scripture, despite other researchers arriving at very different conclusions. In 1928, for example, Dayton Miller stated, quote, the effect of ether drift has persisted throughout. After considering all the possible sources of error, there always remained a positive effect, close quote. Einstein was aware of Miller's work. In a letter to Edward E. Slosson, he conceded that
Should the positive result be confirmed, then the special theory of relativity, and with it the general theory of relativity in its current form, would be invalid. Experimentum summus judex. Only the equivalence of inertia and gravitation would remain. However, they would have to lead to a significantly different theory.
although Einstein cast the ether aside, Maxwell's theories on electromagnetism require it, and if light is a particle or quanta moving through a vacuum, as Einstein proposed, then how can it display wave-like properties? In other words, does the ether begin to explain the wave-particle duality paradox? The ether can be thought of as a fine elastic medium or plenum that permeates everything. In summary, how can nothing wave? Quote, Einstein, in his special theory of relativity, postulated that there was no medium called the ether, but Maxwell's theories of electromagnetism requires it, and Sir Oliver Lodge saw the ether as crucial to our understanding. So, Einstein at a stroke removed any possibility that he or his followers would find a link between electromagnetism and gravity. It served the egos of his followers to consecrate Einstein's ideas and treat dissent as blasphemy, close quote, Wolf Thornhill. In 1998, physicist Tom von Flandern authored a paper in Physics Letters A that is still regarded as one of the best refutations of Einstein's relativity. Van Flandern argued that Lorentz's version, which incorporates the ether through which all matter moves, is superior based on experimental observations. Lorentz and Einstein's version of relativity are similar, but with one significant difference. The speed of light is not a limiting factor in Lorentz equations. Van Flandern argues that the speed of gravity is faster than the speed of light, consistent with Newton's laws, which declare gravity to propagate near instantaneously. Einstein and his fan club love thought experiments, so here is another one. To spooky action at a distance, quantum entanglement also lends support to discredited ether models. Think about it like this. Imagine light as particles sitting on a giant conveyor belt. The belt and the particles travel slowly relative to the vastness of the universe. However, when turned on, the motion of the belt is instantaneous at either end. Could the hypothesized ether act something like a conveyor belt in this respect, effectively hosting differing wave motions? It can also be argued that if gravity propagates between the Sun and the Earth at the same speed as visible light, the Earth would double the distance from the Sun in 1200 years, which isn't happening. Many other notable physicists, besides Newton and Lorentz, also concluded that orbital calculations must be made using an infinite speed of gravity. Sir Arthur Eddington's orbital calculations rely on gravity having an infinite speed, and Pierre-Simon Laplace calculated gravity to have a speed of at least 10 to the power of 8 times the speed of light. Does this variation on the Michelson-Morley experiment verify the ether? When the equipment is turned through the vertical, an interference pattern can be seen, a pattern that does not manifest in standard experiments. The implication for some is that gravity and the ether are somehow connected, and therefore we see an interference wave-like pattern when the apparatus aligns with the Earth's gravitational field. In the comments, some suggest this could relate to mechanical stress, but the apparatus looks robust, so the observations could potentially represent a new discovery. In a groundbreaking article published in Physics World, some cosmologists proposed a mysterious substance known as quintessence as an alternative to dark matter and dark energy. This bold idea arose from mounting frustrations with the persistent inability to detect these elusive phenomena, sparking claims of a potential revolution in cosmology. The term quintessence traces back to ancient Greek philosophy, where it referred to a sublime fifth element beyond air, earth, fire, and water that represented perfection. The similarities between this concept and the long-debated ether theory will not be lost on its adherents.
I believe that I have really found the relationship between gravitation and electricity, assuming that the Miller experiments are based on a fundamental error. Otherwise, the whole relativity theory collapses like a house of cards.
Einstein was once asked how it felt to be a genius. As legend has it, he responded, "I don't know, ask Nikola Tesla." Tesla is to alternative or underground science as Einstein is to popular science, a cult hero. However, while Einstein's work was confined to theoretical physics, Tesla's life was characterized by practical achievement. Renowned for his groundbreaking work in electrical engineering and electromagnetism, he is sometimes hailed as a man who invented the 20th century. Quote, "Tesla has contributed more to electrical science than any man up to his time," close quote, Lord Kelvin. As a practical man and inventor, Tesla's eventual clash with Einstein's more theoretical approach to physics was perhaps inevitable. This divide may have contributed to Tesla's marginalization in his later years, when theoretical physics, mathematics, some say, gained dominance in the scientific community. Quote, "Today scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality," close quote, Nikola Tesla. Tesla, who also insisted on the existence of an ether, was a vociferous critic of Einstein and general relativity. Quote, "Magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar clothed in purple, whom ignorant people take for a king. Its exponents are brilliant men, but they are metaphysicists, not scientists," close quote, Nikola Tesla. While Einstein achieved fame and fortune during his lifetime, Tesla passed away in relative poverty and obscurity. It is sobering to consider that, without the internet, many might never have known his name. Behind every great man, there is a great woman, or so the saying goes. Einstein met his first wife, Mileva Maric, at the Zurich Polytechnic Institute in 1896. While there is some debate among historians about the extent of her influence, it is generally accepted that she collaborated with him on some early papers. In 1921, she received the Nobel Prize money he was awarded as part of their divorce settlement. By the end of their classes in 1900, Mileva and Albert had similar grades, 4.7 and 4.6 respectively, with the exception of applied physics. Here, Mileva scored top marks, 5, but Albert only 1. By this time, it was already clear that grounded science, experimentation, was not Einstein's strength. Henceforth, his work would focus on Gedankenexperimenter, thought experiments. It seems he was aware of problems with this approach all the same.
Propositions arrived at by purely logical means are completely empty as regards reality.
A little refresher on epicycles already mentioned probably wouldn't hurt because they highlight an important philosophical point. Although math-based models may enable accurate predictions, it doesn't necessarily follow that they reflect underlying reality. Planetary orbits were once believed to be perfect and circular. When this was proven false, a mathematical workaround was devised. Imaginary points were placed on the original circular orbits, creating additional orbits. This gave rise to epicycles, from the Greek epikulos, meaning circle moving on another circle. Although mathematically elegant, the model failed to reflect the elliptical orbits of planets. Quote, "The fact that an opinion has been widely held is no evidence whatsoever that it is not utterly absurd," close quote, Bertrand Russell. Moreover, while gravitational equations predict celestial motions with remarkable accuracy, gravity's fundamental nature still remains mysterious. Quote, "There is no model of the theory of gravitation today other than the mathematical form," close quote, Richard Feynman. The Ptolemaic model survived for centuries, from 160 AD until Copernicus and Kepler in the 16th century, in fact, largely because it didn't threaten geocentrism and, by extension, the authority of the Church. Isaac Newton described gravity as an instantaneous or near instantaneous force. However, he conceded he did not understand the mechanism and had to settle for describing it mathematically. Quote, "But hitherto I have not been able to discover the cause of those properties of gravity from phenomena, and I frame no hypotheses," close quote, Isaac Newton. Einstein solved this problem by factoring in time as an additional dimension, the fourth dimension, resulting in alleged space-time curvature. But has he effectively replaced a mathematical description with a mathematical abstraction? Gravity was no longer a force, but a property of space. In classrooms today, Einstein's solution is sometimes illustrated by rolling balls around on suspended rubber sheets, with the smaller balls being attracted to the larger mass in the middle, as if falling into the well of space-time. This self-evidently relies on gravity as its own explanation. It's a classic case of circular reasoning. Stephen Covers explains the fundamental flaws in the math-based speculations behind space-time curvature, and he does so in plain language. Sir Oliver Lodge, a respected scientist, once mused, if a special geometry has to be invented to account for a falling apple, even Newton might be appalled at the complications which would ensue when really difficult problems are tackled. This sentiment captures the ongoing struggle to understand gravity's true nature without resorting to abstract geometries. The speculative concept of curved space leads directly to some interesting mental gymnastics. Quote, a straight line is a special case of a curve. It's a curve which is uncurved, close quote, Leonard Susskind. You really couldn't make this stuff up. Time dilation is often cited as conclusive evidence for special relativity, but could bias confirmation be the significant factor here? In 1972, Haveli and Keating performed experiments that purported to confirm special relativity. The evidence was derived from the differences in time recorded by cesium clocks transported in aircraft moving east and west. However, the results were contested by Dr. A.G. Kelly after examining the raw data. He concluded that the published outcome had to be averaged in a biased way to claim such a high degree of precision. Also, Louis Essen, the inventor of the atomic clock, published an article in which he discussed the inadequate accuracy of the experiments. Essen concluded that the theory was no more than a bunch of contradictory assumptions, together with actual mistakes. It is important to add a caveat to the above. When time contraction and length dilation can be observed, it doesn't lend credence to the fantastical space-time framework. An interesting website, antirelativity.com, has this to say, quote, Poincaré's advancement of Lorenz's ether is mathematically indistinguishable from special relativity, while being utterly opposed to Minkowski's diagrams and formalization of isotropic constancy found in the space-time metaphysics regime, close quote, antirelativity.com. GPS is often cited as conclusive proof for general relativity, but this 1996 paper, published by the GPS Joint Program Office, appears to challenge this. Quote, the Operational Control System, OCS, of the Global Positioning System, GPS, does not include the rigorous transformations between the coordinate systems that Einstein's general theory of relativity would seem to require. Close quote. Adjustments are made, but this is because clocks at high altitudes tick faster, resulting from variations in air density, not gravity. The air is denser closer to the Earth's surface. Atomic clocks are also sensitive to temperature and pressure changes in their orbits. Every schoolchild knows that if you put a stick in water, it will appear to bend due to light refraction. The atmosphere of stars and planets, denser than the space around them, also bends light. Common sense dictates as much. Bizarrely, pop scientists have yet again attempted to interpret this phenomenon within the framework of general relativity. Dr. Edward Dowdier, a physicist and laser optics engineer, formerly with the NASA Goddard Space Flight Center, has derived a mathematical solution for lensing using refraction. Dr. Dowdier notes that observations of solar lensing occur in the plasma ionized atmosphere of the Sun, aligning with the predictions of refraction, rather than with varying elevations from the mass of the Sun, as suggested by gravitational lensing. Additionally, he emphasizes the absence of gravitational lensing effects in stars that orbit rapidly around the Milky Way's galactic center, further challenging the conventional interpretation. Quote, evidence of gravitational light bending at the site of Sagittarius A, as is predicted by the light bending rule of general relativity, is yet to be observed. Close quote, Dr. Edward Dowdier. KISS, keep it simple stupid, is the expression that springs to mind.
I have deep faith that the principle of the universe will be beautiful and simple.
Too bad that, for the time being at least, complex and esoteric math shields so much institutional science from robust scrutiny. Known as the n-body problem to astrophysicists, gravitational models may work fine for two bodies, but they break down or become chaotic when three or more bodies interact over time. This is a big problem, given that there are 9 significant bodies in our solar system, not to mention the many moons that, in turn, orbit most of these. Given the math doesn't work out for 3 or more bodies, The fact that our solar system hasn't already descended into chaos is nothing short of a miracle. As a general rule, of course, science shuns the miraculous, the Big Bang notwithstanding. Again, this reminds us that the door must be left open to other ideas concerning the apparent stability of our solar system and, therefore, the nature of gravity. Quote, what causes gravity and mass? These questions still baffle all of us. Rather than the end of science being nigh, we are still near the beginning of the cosmic quest. Close quote. Martin Rees, former Royal Astronomer. To reiterate, while mathematical models may enable successful predictions within certain frames of reference, it does not necessarily follow that they describe reality with the same degree of accuracy. Ironically, Einstein probably put it best. Here is that famous math quote again.
As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality.
In addition to dark matter and dark energy, black holes are often talked about today as if they were real. Consensus scientists who describe them as one of the most successful predictions of relativity generally choose to ignore the fact that Einstein himself dismissed the idea. In a 1939 paper from the Annals of Mathematics, he concluded that the black hole hypothesis was not convincing and that the phenomena did not exist in the real world. The paper is now hidden behind a paywall, but there is also reference to it at history.com. The black hole concept originally began as a placeholder because we witness compact energetic activity at the center of galaxies, and because theoretical physicists work with only one tool in their box, gravity. Wow, when you are a hammer, I guess everything looks like a nail. Bizarrely, pop science describes black holes as points with zero volume, infinite density, and infinite mass. Think about that. Does the concept sound credible, or more like another mathematical abstraction? Quote, this is how astronomers and cosmologists do science, fraud by means of mass media induced mass hysteria. It beggars belief. Think about it. According to the astronomers and cosmologists, the finite mass of their black hole is concentrated in a physical singularity of zero volume, infinite density, and infinite gravity. But no finite mass has zero volume, infinite density, and infinite gravity. Close quote. Stephen Crothers. Claims that a black hole has been pictured for the first time at the center of galaxy M87 are at best contentious. The pictures of this supposed black hole were composite and have been widely criticized. From universemagazine.com, quote, Makoto Miyoshi, a researcher at the National Astronomical Observatory of Japan, and his colleagues say that the high-energy jet is missing from the EHT photo. Moreover, in the new photo of the black hole M87, in a panoramic view, there is no ring of light in the form of a donut, which means that the photo of 2019 turned out to be false. Close quote. Academic science uses black holes to explain the speed plateau of spiral and ring galaxies, from whose interior plasma jets have been observed. It has been noted that plasma focuses or plasmoids can produce the same effect in the laboratory. Additionally, Leonard Susskind and Stephen Hawking argued for decades over the preservation or destruction of information within a black hole. This was handed down for posterity by Susskind in his book The Black Hole War. The argument ended shortly before Hawking's death in January 2014, with Hawking's admission that there is no event horizon and therefore no black hole in the sense of the theory, and even recommended redefining black holes as a five-dimensional space, whatever that might mean.
Whoever undertakes to set himself up as a judge of truth and knowledge is shipwrecked by the laughter of the gods.
Einstein's friendship with Immanuel Velikovsky is often overlooked by history. While Einstein is still celebrated, Velikovsky remains persona non grata, and many would rather forget the embarrassing episode in scientific history whereby Velikovsky was attacked and silenced by underhand means. Quote, the suppression of uncomfortable ideas may be common in religion or in politics, but it is not the path to knowledge, and it has no place in the endeavour of science. We do not know beforehand where fundamental insights will come from, and the history of our lovely and mysterious solar system shows clearly that accepted and conventional ideas are often wrong. Fundamental insights can arise from the most unexpected sources. Close quote, Carl Sagan. Velikovsky famously wrote Worlds in Collision, the best-selling book that argued against gradualist dogma, and proposed that electromagnetism played a more important, if not dominant, role in celestial mechanics. It was published in 1950 and occupied the #1 spot for some time. Even before its appearance, however, the book was surrounded by furious controversy. Macmillan, intimidated by threats from academics and scientists, transferred the book to Doubleday. Furthermore, a number of prominent scientists and academics engineered the dismissal of the veteran senior editor at Macmillan, despite his 25 years plus service after he accepted Worlds in Collision for publication. They also had the director of the famous Hayden Planetarium fired, merely for proposing to mount a display of Velikovsky's cosmological theory.
A dictatorship means muscles all round and consequently stultification. Science can flourish only in an atmosphere of free speech.
In 1963, the famous geologist Harry Hess wrote to Velikovsky, quote, "You have, after all, predicted that Jupiter would be a source of radio noise, that Venus would have a high surface temperature, that the Sun and bodies of the solar system would have large electrical charges, and several other such predictions. Some of these predictions were said to be impossible when you made them. All of them were predicted long before proof that they were correct came to hand. Conversely, I do not know of any specific prediction you made that has since been proven to be false. I suspect the merit lies in that you have a good basic background in the natural sciences, and you are quite uninhibited by the prejudices and probability taboos which confine the thinking of most of us. Whether you are right or wrong, I believe you deserve a fair hearing." Close quote. Harry Hess. Venus, of course, was supposed to be a twin of the Earth, so its high surface temperature was a big surprise to orthodox science. Today it is sometimes referred to as Earth's evil twin. Significantly, Sagan proposed the runaway greenhouse effect to account for this, which led directly to claims surrounding global warming and, subsequently, climate change. Einstein's last interview before his death was with science historian Bernard Cohen. Regarding Velikovsky's book, Worlds in Collision, Einstein had this to say.
It is not a bad book. No, it really isn't a bad book. Can a scientist's contemporaries tell whether he is a crank or genius when the only evident fact is his unorthodoxy? A radical like Kepler, for example, challenged accepted ideas. It must have been difficult for his contemporaries to tell whether he was a genius or a crank. There is no objective test.
Mainstream physics holds that electromagnetism and gravity are unrelated because the former can be shielded while gravity cannot. This assumption oversimplifies the relationship. Both forces diminish with the square of the distance, are proportional to the product of interacting masses or charges, and act along the line between them. Historically, notable pioneers in physics sought to reconcile gravity and electromagnetism. Michael Faraday said, quote, "No terms could exaggerate the value of the relation they would establish." Close quote. Henry Poincaré echoed this sentiment, proposing that what we call mass might, ultimately, have an electromagnetic origin. Quote, "What we call mass would appear to be nothing but an appearance, and all inertia to be of electromagnetic origin." Close quote. The US Department of Navy Research even appears to support this idea. In 2016, the Navy filed a patent for a mass reduction device utilizing electromagnetic waves. This concept contradicts the standard notion that gravity cannot be modified by electromagnetic influence. Support for anti-gravity is considered taboo because it implicitly undermines Einstein's general relativity theory. Aligning with ether models, the paper refers to quantum vacuum plasma QVP as the electric glue of our plasma universe.
The special theory of relativity owes its origin to Maxwell's equations of the electromagnetic field.
When Einstein was asked, "Who is the smartest person you have met?" he responded, "My chauffeur." When asked why this was, he said,
He stood in for me once when I was feeling ill. Having heard my lecture more than 300 times, he was able to repeat it word for word and even answer questions afterward.
By way of tragic irony, it might be claimed that relativity has been repeated parrot fashion ever since, with casual disregard for competing ideas. It has been argued that traditional empiricism, based on observation, hypothesis, testing, and theory, has been replaced by theoretical physics, sometimes jokingly referred to as mathematics, in the light of its many well-documented historical failures. Adding weight to this suspicion, Stephen Hawking appeared to admit to as much. Quote, "You really can't beat a good mathematical theorem," close quote, he said. With many now claiming that Einstein has put science back more than 100 years, it has to be asked, was it Einstein's rejection of the ether and classical physics and his obsession with mathematical modelling that marks the fork in the road where science took a wrong turn? Only time will tell, but not in the space-time curvature sense, one might add.
The measure of intelligence is the ability to change.
To be fair to Einstein, he was a modest man and a reluctant hero. The truth is that others ran with his ideas, and ran, and ran. Today they are still running around like dogs sniffing each other's butts. Typical of this breed is the British professor Dr. Brian Cox, who made the seamless transition from pop star to pop scientist. He was a keyboard player with Dee Ream in the 90s. They had a UK #1 hit with "Things Can Only Get Better." I'm not saying Cox is any worse than any of the other talking heads paraded on television today, but things really don't seem to be getting any better. Daring to question relativity remains an anathema, and doing so is liable to draw comparisons with flat earth quackery. Cox is the UK's answer to America's Neil deGrasse Tyson. Several luminaries regard Brian Cox as the best man to front BBC scientific programming moving forward, which reminds me of Fred Hoyle's famous words. Another former Royal Astronomer, Hoyle was critical of peer review and the graduate school system and their abject failure to encourage independent thinking. Prophetically, he summed up, "The road ahead is hammered out."
Unthinking respect for authority is the greatest enemy of truth.
A famous line from Shakespeare's Twelfth Night seems apposite. Some are born great, some achieve greatness, and some have greatness thrust upon them. I submit that Einstein belongs in the latter category. He was more victim than genius at a time when science took a wrong turn and mathematical modelling began to take precedence over traditional empiricism. Doubt is supposed to be at the heart of good science. The funny thing is, though, while Einstein's fan club hang on almost every word he uttered, they ignore his many doubts. The last word belongs to him.
You can imagine that I look back on my life's work with calm satisfaction. But from nearby, it looks quite different. There is not a single concept of which I am convinced that it will stand firm, and I feel uncertain whether I am in general on the right track.